Hi, my name is Joe Milanese. I'm with CS Engineering, and we're putting together this video in order to explain the basics of cap chute adjustment. First off, what do we mean by cap chutes? You can see here on the table saw in front of me, there's a number of samples. If you're in the food or beverage packaging industry, or in the cap manufacturing industry, you've probably seen these before. They're used to transport the parts from a sorting machine to a capping machine or some sort of assembly machine, say a printer. This construction is very common in the industry. You have a number of laser or water jet cut plates, and then you have 1/4 inch OD tubing. It's all stainless and it's a weldment. There's variation. Some people will use 3/16 solid or 1/8 solid. The reason you can't use 1/4 inch solid is it's really much too hard to bend and you could never hold the tolerances at all. The reason they're made from this relatively lightweight material is often they have to be changed so that you don't want them to be too heavy. But even more than that, because you need to be able to bend them to many different shapes so that you can connect any XYZ points and any angular differences between the inlet and the outlet. That's the advantage of making them this way, but one of the disadvantages of making them this way is if you've ever made a weldment from lightweight, a large weldment from lightweight material, you know that there's going to be movement of the part once you take it off the fixture, regardless of what you do to hold it while it's being welded. What that means in practice is when you get out to the field, there have to be fine adjustments. If you think about it, even if the part didn't move, there often would have to be these adjustments because floors are not perfectly level, and this can't be taken into account in the CAD model of how the whole system fits together. So making these too rigid would, in many cases, make them impossible to install. So there's really no way of avoiding this. And it's something that, if you're in this business, you should learn how to do. If you look at a long sheet like this, the amount of adjustment you have is really very large. Even just deflecting under its own weight, a chute this length might be 3 or 4 inches different from the center point where there's zero stress on it. And that's before you've even permanently bent the part. If you would, by permanent bending, you could probably move this 1 foot or 2 feet easily. But we're going to start with a relatively small piece, just because it's easier to film and easier to demonstrate. We'll be taking this chute and showing how we can change both the amount of bending in a plane and also the amount of twist along its axis in order to get the holes to line up in the field. All right. Here's a small piece of chute. It's positioned against a stop that I locked to the table and squared up against this end. And you can see it puts the end of the chute right at the edge of the table saw table. So I'm going to take this over to the vise and modify it, show you what I do, and then come back here and see how much we've moved it. Okay. Okay, got the chute in the vise, and we're going to bend a little bit at a time. The main idea is not to try and bend the whole thing at once, but to try to bend each little section of the chute a small amount and have it add up to
the total that you want. If you try to put all the bend in one place, you're going to affect the clearances more than you would like. So here I go. I'm going to start putting some force. This is a short one, so it takes a little bit of effort. On a longer chute, it's not as difficult. I'm going to grab it here too and give it a pull here. Get it right on the end. I've shifted it in a little bit, adjust some more. Okay. And finally, pull back here a little bit. Let's see how we did. So you can see it's possible to move it this short a distance, almost an inch, which is quite a bit. If you're talking about long distances, then an inch is nothing. But for something, this is about, say, 16 inches long, that's probably close to the limit of how much you would want to move it. I think next we're going to show you how you can change the angle a little bit. If you look from the end here, you've got a slight angle on the end of the chute. If you can also twist these a little bit at a time to get more, if the whole pattern was misaligned, to bring it in. So let me show you on the mill how we do that. Twist them by clamping the plate and then putting a torque on it with a large channel locks or pipe wrench. And now you can see if I bring this plate back into the same position, that we've rotated that plate probably, looks like about 15 or 20 degrees, which is a good bit. Have the chute connecting on both ends. Sometimes the movement of the chute will be enough, although not usually, but it can be, that will change the clearances in a way that would prevent the cap from going smoothly through the chute. So if the clearance has been made too much and the cap can escape, you can reduce the clearance by going between two tubes like so. And it doesn't take much. You can see this is in the elastic range. See how it pops back? But if I go like this, now I've moved it. And the clearance there is slightly less than it was before. And that will stay unless somebody hits it with a hammer or bends it with more force than you just applied. Sometimes, particularly if you're twisting, you're reducing the clearances, and then you want to open it up.
Good, like yourself.
Hey, how you doing? You got when you need to add clearance, it's always better to work on the rods that are bent towards the part rather than the ones that are bent away from the part. Because you can easily bend this out without changing the shape of the chute, and that will give you the part room to come through. So if the part is tight, you want to adjust these rods. And the mistake that people often make is to try and use a screwdriver and work against the other rods, but then you're bending things that you don't want to, and that can lead to other problems. So really what you want to do is always, when you're bending the individual rods, get a bar that's considerably stronger than the rods, make it span two plates, and then use something to pull it, just that rod, and adjust it. And you can see it was quite easy for me to bring that out, and now that's got significantly more clearance for the part that's passing through. All right, guys, I hope you got the general idea of how to adjust these chutes. If you have any questions, you can always call here, CS Engineering, 440-953-9878 for any adjustment questions. And please forgive our our low level of production values. I had to answer the phone a few times in the middle of this. Thanks. Bye.